Hello and welcome to the Traefik and msHOWTO webinar series part 2. I am Mert and today I will be your co-host with Brian Christner. On the previous episode, Brian has showed us how easy to migrate from version 1.7 to 2.x. And today Jakub Hajek is going to show us the new features of version 2. Brian and Jakub, welcome.
Thank you. Hello,
Thank you.
everyone.
Okay, so shall I start, Mert?
Sure. This is your show today.
Thank you so much. I hope you can hear me very well and you can also see me very well. Let me share my screen. Please confirm that you're able to see my slides. Yeah. Okay, so today we are going to talk about what are the features in the newest version of Traefik, that is 2.x. And we have also subtitle, that is what has Canary deployment had to do with a scrambled X. So let me go just briefly introduce myself. I'm
not seeing the slides. Is everyone else seeing the slides?
What? Just a second. Thank you, Brian. Sorry. Let me start once again. Can you see it right now?
Yes. Perfect. Thank you.
Oh, thank you. Sorry. Okay, so let me start once again. Today we are going to talk about the Traefik 2.x and the features that have been delivered by team in the latest version. We have also a subtitle that is about the Canary deployment, and I came up with the story how to compare Canary deployment to the delicious scrambled X, but it will be a little later on. Let me just briefly introduce myself. My name is Jakub Hajek. I'm a technical consultant, actually SRE engineer. I work for my own company, Cometari. And I started my career a couple of years ago. So I remember quite old times when we used the servers with no any automation tools that make our life now much easier because we can automate everything. We have the containers, we have a cluster management tools, we have a Traefik, we have other solutions. So that's how it looks right now. So I have a lot of experience working in a different companies with a totally different technologies. As I mentioned, I'm own my own company, and what we are trying to do, we're implementing DevOps culture, DevOps strategy into different companies, different companies. We provide also consultancy, workshops, and we have a very strong team with a software developers because we also provide software services. When I'm not working in a computer, I like to ride on my mountain bike. I practice boxing, and I'm a father of my son, Julian. So that's all about me. Let me pass the voice to my colleague, Brian.
Hi, everyone. My name is Brian Christner. I had the pleasure to work with Patricia, Jakub, and Mert. They're the Traefik specialists. I'm just here to assist and answer questions in the background. So again, my name is Brian Christner. I am also an SRE and co-founder of 56k.cloud. My background's in containers, cloud engineering, and I'm also a Docker captain. Basically, I just get a bunch of stickers. That's all it boils down to. And I just hand it over to Mert. Thank you very much.
Hello, Mert.
I am waiting for the slides.
Sorry.
Yes, thank you. And thank you, Brian, Jakub, and Patricia. And I am Mert. I am from msHOWTO. It's a big community in Turkey. And I am actually a software developer, but I love DevOps, cloud. And I am also an active member of the Cloud Family. It's another community and based in United Kingdom. I like mountain biking, and also I am a Traefik ambassador. Thank you.
Thank you, Mert. Thank you, Brian. So let me back to my presentation, on my slides. So today, as I mentioned, we are going to talk about the features delivered in Traefik 2.x. And just briefly, the agenda for my presentation is that I will go through few theoretical slides Then I would like to explain you what are the features delivered, what is the Canary deployment, how to use it. And then I will go through, I will show you my code, which I use to do Canary deployment on Kubernetes on Action K3s. And it will be live demo, so hopefully everything should work as I designed, as I prepared. It's live demo, so everything can happen. Okay, so for those who are not familiar what Traefik is, let me just explain what is it Traefik. So Traefik, it's a cloud native edge router, and what we would like to remember from that, it's not the web server, it's just a router that can catch the request that is coming into the traffic to the specific open port. It might be HTTP, it might be HTTPS or any other port, and pass the request to router. And the router has a specific configuration to redirect the incoming request to the specific service. And service can be represented by servers, can be represented by containers, because we are in the container world. We usually use containers. However, Traefik also works perfectly with the standard bare metal servers or VMs. In the middle, we have a middlewares, and middlewares. So those are something that can tweak HTTP requests. It can assign specific HTTP headers, and it will be shown a little later on in my examples, because we need to add headers to play with a Canary. It can also do some basic authentication, whatever you like it. And middlewares can be reused. So once you define any router, you can easily assign to many routers. And this is, as I mentioned, it's a native solution, so it's specifically designed to work with cluster orchestration tools. Because other ingress controllers, like for example Nginx, there are also web servers, and they work perfectly with like ingress. But in this fact, Traefik, it's a dedicated, designed for working like a reverse proxy, like a router for a cluster management solutions. So what are the key features delivered in version 2? So if you remember our previous presentation, we talked about the migration from version 1 to version 2, and there are a lot of changes. So first of all, what has been implemented is the changing of the front-end, back-end, and rules. So front-end refers to router, back-end refers to service, and rules refers to middleware. And this is the very major change that you have to understand, and that you have to update your configuration using Brian's advices from the previous presentation. And I mentioned on the previous slide that it is also a HTTP router. It's HTTP router. However, in the newest version, there are also support for other protocols. So we can use a TCP, we can use UDP and gRPC. So you can use a different services, not only HTTP, and use this Traefik as a router for your microservice. What I like the most from that version, it's integration with Kubernetes. So it's done through the CRD, custom resource definition. So you can create your own objects to work with Kubernetes and create configuration for your system, for your application. So that's the very nice feature. It also provides Canary deployment that is achieved through services and the load balancer. So we use weights between two services to send the traffic to the different services, and it will be the main part of my live demo. The same, we have a similar feature. We have a mirroring, so it can mirror the incoming traffic to your traffic server and send that copy of the request to other service. And it's a nice feature because the response of that request will not be sent back to user. So let's imagine that you are testing application and there are some problems, there are some issues. So those issues will not be sent back to your user. So it's quite nice feature that you can definitely should try. And of course, we have a session stickiness. So if you require from your system to be always, because if you are talking about the routing, we use a round robin. So if you have many servers in a pool, that request will be sent to the random, let's say to the random backend, random server. If you use a stickiness based on cookie, you can be sure that the incoming request will be sent to the same backend. So this is sometimes used for a different kind of an application. So that's all about the key features. Let me just briefly show you how the configuration looks like. And it also refers to the version 1 and also to the version 2. But from my perspective, it's important to understand that we have two types of the configuration. So one of them is a static configuration that allow you to create entry points and define the providers. So a provider, it can be a Kubernetes, Docker Swarm, or let's say file. And those things cannot be changed without restarting the traffic, because it's loaded on the startup time, and then it cannot be changed. You need to restart if you are going to expose new port or provide another provider information. From the other hand, we have something which is dynamic. So all this configuration, like routers, services, middlewares, and certificates, can be done, can be changed, can be updated dynamically. So it doesn't affect your user. So you can change something, you can update service, you can change configuration of your router, and Traefik will automatically discover new changes and gracefully restart the service without affecting your user. So it's worth to remember that there are those kind of configuration types. And now let me go, what's about the Kubernetes and CRD? What are the available resources that have been created that you can use while you are creating your configuration? So first of all, we have a ingress route. So it's a HTTP. It is responsible for a router. It's HTTP routing. So when you use that object in your YAML file, you are creating ingress route. Middleware, it's an object. It's a resource that you can use for tweaking your HTTP request. So this is what I presented on one of the previous slides, that you have a middlewares to tweak HTTP requests on the router level. And of course, you have a traffic service. And traffic service, it's a abstraction layer for HTTP load balancing and mirroring. So you can create the traffic service and expose port using that objects. Analogically, we have an ingress route TCP that is responsible for TCP routing. It's just a TCP router. So similar to HTTP, but it works with a different protocol. TLS options, it's just a TLS connection parameters for SSL certificates. So this is how it looks like, and all of those objects will be used later on in my demo presentation. So you will show how I'm using those objects. Moving forward, so now one of the coolest features that I like the most from the Traefik, and it's, let's say, quite easy to understand, very straightforward approach, how to use Canary deployment and traffic mirroring. But in order to move forward, let me just explain you what is Canary deployment and how we are using it from the historical perspective. So on the picture, you can see there is a coal miner that is keeping a cage, and in a cage we have a bird. That bird is a canary. So coal miners used canaries in coal mines to detect toxic gases, especially carbon monoxide. It was done in the 20th century. So it's they used those birds as an early warning for them, because the birds were able to detect the gas, and if the coal miners seeing that the bird is distressed, they have enough time to escape from the dangerous place. So the birds were able to save them life. So now we are using very similar approach because we are releasing one applications, one service, one new version of the application, and we are testing on the live production environment. And we can see if something is happening and our service is not behaving correctly as we expected, we are not meeting our KPI, we can easily roll back to the previous version. So that's thanks to those birds, we can use the same Canary approach. I also came up with a quite funny story about that I'd like to share with you. It's about the breakfast. Let's imagine that you are preparing a delicious breakfast every day, and the main dish it's scrambled eggs. And of course, that scrambled eggs contains some of the few ingredients. Of course, it's a chicken eggs. It might be a spring onion. It might be also different seasons, whatever you like it. And one day you decide, okay, I had enough of chicken eggs. I would like to replace chicken eggs and give a try of quail eggs. But you don't want to do it radically at one time, just to change everything, to cut down chicken eggs and make a scrambled eggs from quail eggs. You would like to do in a specific period of time. So every day you are replacing one chicken egg to quail egg. And you are doing that every day, let's say during 1 week. And by the end of the week, you already replaced your breakfast, your scrambled eggs, the main ingredient from chicken egg to quail egg. So you have done Canary approach. Your body had enough time to adapt new ingredient, probably keeping the same quality of your breakfast. And referring to my examples with a breakfast, scrambled eggs, the breakfast can be your entire system that contains multiple microservices. And let's imagine that scrambled eggs, this is your core service, the most important service in your application, and other ingredients, there are less important services. And you are changing the core, you are releasing the new version of your core service, and you are doing that. So this is the scrambled eggs, and you are doing it in a specific period of time. So this is how it works in referring to my story. From the technical perspective, going back to the technical perspective, Canary deployment, once we are talking about Canary deployment, we need to distinguish what is it deployment and what is it release. So deployment, once you have an environment, you can deploy a few versions of your app, of your specific service, let's say version 1, 2, and 3. But traffic, the users, the majority of your users goes to the only one version. Once you decide that, okay, I'm ready to switch to version 2, I'm making a release. So our environment can keep few versions of application, of a service. So this is something that is very important to understand once we are talking about the deployment. And it's much easier to do if you use containers, because you can publish your containers, you can deploy your containers to your environment. And once you are ready, once you make some tests, some smoke tests, you are making a release. And this is how it looks like when we have a traffic that request is sending to the traffic. Majority of our users should go to the version 1. And if you are doing the Canary approach, one of the strategy of releasing applications, we can just route a few users to version 2. And what we can do on version 2, once we have defined any KPIs, we can see if those KPIs are still acceptable for us. We can see what's happening in the log files. If there are no any errors, any issues, we can say, okay, since that application is stable enough, we are making a release and switching from the version 1 to version 2, because we should end up with that with that scenario, with that how it looks, how it's designed on my diagram. So we have just only version 2. We cut off everything from version 1 to version 2, but we've done it in a specific period of time. And again, it depends on your configuration, of your system, how complex is your system, how many dependencies you have between your microservices, because everything works fine in your lab environment. And on production, sometimes we can have a totally different surprises. So again, similar feature that I mentioned at the beginning is the mirroring. It's still the same approach that we can deploy a few versions of our applications, but in that case, the version 2 does not send response back to our users, because in the Canary, if we have any problem on version 2, the response will be sent back to user, but to the only a very 1% of user, let's say. So only a few users will be affected because of the bug that has been created in version 2. In that case, we can test our application in our production environment, and in case of any problems, nothing should be sent to your users, so nothing will be no one will be affected. So it's a nice feature that you definitely should give a try. So I think it's all about the slides. Let me now go back. Let me now go with my demo environment. So a few words what we are going to use in my demo environment. So we will have a cluster that is created using a K3s, and it's 3-node cluster. We use SSL certificates issued by Let's Encrypt, and we use 2 fully qualified domain names, alabs, clabs, cometari.eu. And we use a round robin for those domains, because all of domains are used in AWS in Route 53. So the DNS configuration is done in Route 53. And because we have a 3-node cluster, we can send requests to each of the node using its public IP address. So if you try to use dig alabs cometari.eu and you repeat the that comment few times, you should receive different IP address. So it's a very old feature from DNS, but still very helpful, and definitely I recommend to use it if you of course defined health checks for your servers in Route 53. How to set up cluster in 2 commands? Very simple. What I wanted to point out here is I'm passing the parameter no deploy traffic, because K3s, it installs you by default traffic in version 1. Today we are talking about version 2. So we pass the parameter no deploy traffic, and cluster will be set it up using those 2 commands. So pretty simple. You can definitely give a try at your home environment in a lab. A quotation from a very famous person: "Talk is cheap, show me the code." Let me turn off my presentation, and you should now see my files, my Visual Studio and terminal.
Confirmed.
So, thank you. So in order to use Kubernetes CRD, we need to create some custom resource definition, and it's just everything is in directory prepare. We create a separate namespace called Traefik, and in that namespace we are adding some specific objects that we are using later on in our configuration files. So this is actually what I downloaded from Traefik repository from GitHub. So I'm not going to talk more about it. This is what team provided, and it works. So let's move forward. It's prerequisite in order to use CRD. You are just creating objects. So if you deploy it, everything, your objects, you can use a ingress route, you can use a middleware, you can use TLS option. So once you deploy it, everything should work correctly. Let me spend some time on Traefik, because this is how we are going to deploy Traefik. So it's a standard deployment from Kubernetes, and we are here just installing one Traefik, one replica. And in my example, I'm passing the parameter from file. I did it on purpose because I would like to show you that you can use a different approach. You can put everything in your TOML file and use a file from like a file provider. Of course, you can use a CLI comments, but in that case, I use a file provider. We have health checks that are very important, and Traefik expose specific endpoint that you can send the request and make sure that your Traefik instance is up and running. So we use a readiness and liveness check running on the port 9000, and it's just available on the endpoint ping. Standard resource limitation. We are exposing ports for HTTP, HTTPS, as well as for ping for that health check endpoint. Volumes, because we are storing volumes in a PVC, so we are creating PVC for volumes. For Let's Encrypt certificates, and of course we use the 2 volumes for configuration and for dynamic configuration. I will just show it later on in my files how it looks like.
Jakub, can you please increase the font size?
Sure. Is it better now?
Yes, thank you.
It is. Yeah, welcome. So we use the config maps to inject configuration for Traefik config and for custom config, and standard object for service to expose sports, and PVC for certificates. So let me now show you the configuration. So we are injecting TOM through the config map, and this is the configuration this is the file that is used in a startup command to load the configuration. So entry points, log level, providers. So we use a providers Kubernetes CRD and providers file, because we have a directory conf.d, and every file that is stored in that directory will be automatically tracked by Traefik. Once you update the configuration, once you add new changes to the file, it will be automatically reloaded, gracefully reloaded. Prometheus metrics and 2 certificate resolvers. I recommend to use 2 resolvers if you test something. If you play with your environment, you can use a staging environment, because if you make any mistake, you can be blocked by Let's Encrypt. So it's better to use a staging environment and easily switch between those certificate resolvers, sorry. And config maps for custom configuration. So we use 2 files, tls.toml, then we are tuning a little bit our configuration of TLS, and 2 middlewares. One is called default headers, and second is called security headers. As I mentioned, those 2 middlewares can be easily used many times on your router, so you can easily assign your middlewares to your routers. So it's reuse of the code. So very nice feature. And now let's see how it's designed with a dashboard, because Traefik has a beautiful dashboard that can be used even for engineers to see how it's designed, how our services are designed. You can also use for your C-level management to present, okay, let's have a look what we have inside, how our system is designed. So it's very nice visualization. I will show you a little bit. I will show later on how it looks like. So we are here using one of the custom objects that I created. It's ingress route for that for that URL, because we use one matching rule. So based on the HTTP host header, once you send a request to alabs cometari.eu, you should be redirected internally to Traefik, because it's an internal direction to send you back dashboard. So this is how you can design it, how you can configure it. And of course you can use middlewares, because we are going to protect our dashboards using just a basic authentication. So how you can do that? You are just creating a standard secret object in Kubernetes. It's encrypted username and password, and that secret you are assigning in middleware. So this is the object middleware that assign the secret I created in a previous file. So it means that the name of that middleware is out and it has been assigned here. Yes, so I think it's clear. So this is another middleware that is called redirect scheme for, so what we would like to do, we would like to redirect everything from HTTP to HTTPS. And again, it's achieved through the middleware and also through ingress route. So we have a matching rule that's regular expression. So let me catch all requests and redirect them to internally and assign the middleware redirect scheme. So this is how it looks like. So now I think it's time to show you just briefly the configuration. Just let me go once again to the URL. Let me reload it. Because this is deployed, so you can see beautiful dashboard, you can see the routers, you can see services and middlewares. In that example, we don't use anything with a TCP. Everything is done through HTTP, and everything is highlighted to green. No errors, since everything is working as we expected. Let me just go through routers. As you can see, there is one router to catch everything for redirecting from HTTP to HTTPS, path prefix for ping and for metrics. And here what we have, it's our dashboard. So it's a matching rule, use HTTP host header. It's encrypted, so we use SSL for it, and it's redirected internally. The same is done on the metrics, and Traefik expose metrics in open metrics format for Prometheus, and it's done on Kubernetes provider. So let me now go through the services, just briefly have a look what's happening inside. Everything is done through the internally, so no application is deployed yet. And the middleware is just to show you how it works. So some of them are provided from file. So this is what I presented in my Visual Studio. And some of them are done through configuration file from Kubernetes through YAML. So yeah, so this is how it looks like. Let me now go back to Canary deployment. So I prepared very simple application that just display headers from the container, and it's service created using Node.js, and it displays the headers and the version is V1. Second version of application that I'm going to deploy using Canary approach has a very similar UI, mostly the same values. However, the version is changed from version 1 to version 2. So let's see how the configuration looks like. So what we are using right now here, what we're seeing here is a namespace, because it's a good practice to keep everything as separate namespaces. And we are creating a standard deployment, 2 replicas, and we are calling that web app v1 and using that application. So it's a Node.js app running on the port 3000. and standard service. So let me deploy it and let's see how this application looks like. So here I'm connected to my local environment, but I'm connected to my cluster that is running in internet. Hopefully, yeah, cluster is up and running. Seems everything is fine. So let me try deploy that one directory. So key apply -f web app. Yeah, seems it's working correctly. Let me see the pods. Yeah, 2 pods are up and running. We also created ingress route. So let me see whether those ingress routes are correctly created. Yes, we created ingress route web app. Let's describe it and see what's inside. Describe ingress route web app. So it means that we are using the matching rule clabs cometari.eu, and it's already encrypted, protected using a Let's Encrypt. Let's see how that application looks like. So let me go to clabs cometari.eu. Application's up and running. So once we refresh, it just changed the headers, but nothing else is changed. So the version is still the same. So now we have a version 2, and the difference between version 1 and version 2 is just that what we should expect here is to see v2 here. But let me go back to configuration files and to see what we are going to deploy. So let's go to Canary and to services. So now we are creating deployment, right? And we are deploying the version 2. So the name of the service is web app v2, and what we have here, we have just a change. We changed the version name, and we are creating a service to expose the port. So nothing sophisticated here, just a simple configuration. So now let's see for the Canary approach, because we are now creating an object using CRD called Traefik service. The name of it is web app Canary, and we are using 2 services here, web app v1 and web app v2, and we use weights here. So we use that the weight, the value is 3, and here value is 1. So the majority of users should goes to the v1, and the last percentage of the users should goes to the v2. We don't have, using those weights, we don't have influence exactly how many users should be redirected, but you can use a much higher values here, and you see how it will be behaving, how your users will be redirected. And what we are doing here, we would like to expose applications through the ingress route on that port. And yeah, but I would like to show you what changed before moving forward, because I deployed the applications and we create the routers here, a new router here. It's clabs. So we have a standard configuration here, and we have a service that is running here. 2 servers, 2 replicas are actually responsible to handle the incoming request. Seems everything is fine. So now let me deploy the code I just presented, and we should have a 2 version deployed and released. Why released? Because we use a wait here, so we automatically release the version. We can change to 0 and release deploy the applications, but will not redirect the traffic anywhere to the newest version. So let me deploy it. Key apply. Yeah. Objects have been created. Let me see the pods, because we should have a web app v2. Yes, that's just created. And now if you go back to my browser, if I refresh the browser right now, I should be redirected to V2, but I don't have influence on which request I should be redirected to V2. So that's another case. V1, 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 and V2. So now using the way it's defined in my configuration files, I was redirected to V2. So now we can, if you have any KPIs, if you use any service level objectives from SRE engineering approach from we can now have a look what's happening in the applications. If we still are fine with our metrics, we can now move forward with the releasing and switching from V1 to V2. So that's the tricky part. Yes, and also let me show, now you can ask the questions how I can go directly to V2, because now I have a QA, I have a testers in my company, and I would like ask them, guys, can you please go right now to V2 and test whether everything is fine from your perspective. So we can do it using headers and middlewares. So what I created here, I created middleware that is called Let Me In, and I'm using two headers here. So one header is custom, it is for request, and second header is for response. So once I send in my request the header, Canary header, and the value knock knock, I should expect to in a response hello there. So this is how I'm here. So let's have a look on it. So we use two matching rule in that ingress route. The first one is a standard HTTP host, clabs.cometari.eu, and the second is a header regular expression. So once the traffic will catch the request, incoming request, and see that header, it should redirect you to V2 using that middleware that I showed you a few seconds ago. So let's have a look on it. If I'm saying true. So I'm executing the current command. So I'm passing the extra header, Canary header, knock knock, and I'm passing the same HTTP host. Yeah, the same URL. So let's first review the headers, because I sent the header Canary header, knock knock in request. Yeah, that's fine. And in response, we should see hello there. Yes, and we see hello there. And now, based on my configuration that is displayed here, I should be redirected every time to version 2. That is true. So let me repeat that request once again. And yes, I'm on V2. Once again, I'm on V2. So now you can ask your colleagues, just add the extra header to your test scenarios, and you will be redirected to version 2. You can test what's happening in that service. If the logs are fine, if your KPIs are fine, you can now proceed with a deployment, releasing everything and replacing V1 to V2. Of course, it requires some automation, but it's totally different story. So yeah, I think it's all about the demo I created. Let me back to my presentation. Maybe we can just see routers. So yeah, that's the second router I created using that regular expression, that header. If we go to service, so we see that we created a service that is weighted. And we have two services, V1 and V2, and those weights that I presented in my configuration file. So it's everything correctly deployed on Traefik, and it also works correctly as I designed it for the demo purposes. So it's, yeah, I think it's all about the demo. Let me back to my presentation. Demo time. So we've seen how the services are deployed. We see Canary deployment. I haven't presented mirroring because I have no demo, any live demo for it. However, in my repository, because that code is deployed on my GitHub account, you can see how you can use mirroring and test the mirroring. And what are the benefits of Canary deployment? Because it's nice to have that feature, but what are the major benefits? From my perspective, the most beneficial thing that you can validate your application in a real production environment. Of course, you can create many environments, but it's difficult to keep them coherent, keep the same according to the 12-factor apps. We should do that, but it's difficult, and it costs money, and it requires team to maintain those environments. So if you are ready with Canary approach, you can deploy your application and you can test in a real production environment. You can see how users use your applications. You can also test some features. If you use some more advanced features to distinguish the users, for example, geolocation, and you can test some features against specific group of users. So it's definitely very nice feature to further exploring. I just presented examples, so in real production environment, it's totally different story. And in case of any problems, you can easily roll back to the V1. And that's the most beneficial thing, I think, also. And you're also reducing the number of environments to maintain, because you can test on production, right? And the source code I presented is available on my GitHub account. And I think this is everything what I prepared for today. If you have any questions, feel free to ask right now. Thank you so much.
Hey, we do have questions. They're listed, so let's go ahead and go through those, please. One moment, and we can just start at the top. And people in the audience, please feel free to ask your questions in the chat box.
Yeah.
All right, I think we can get started. There's a couple questions, and the first one was, what was the minimum TLS 1.3? Is that a better way to ensure use of 1.3 before trying 1.2? And I found this in the documentation that you can actually select the minimum TLS version. So it's really your choice which version you want to stick to, but it is configurable. You can actually choose which one you want to, which minimum version you want. Do you have comments on that, Jakub?
Yeah, so definitely it's your choice what you are going to use. It was just an example, right? Depending what you are going to prepare, what you are going to set it up.
And the next question for you is, any advice to use Canary and mirroring on a stateful app, specifically regarding database migrations?
Yeah, very good question. So as I prepared here, as I mentioned, it's just a demo. It's just a lab environment. So if you use a stateful application, and your application should be aware that you are going to use a Canary deployment, because if you use some crude create, read, update, delete statements in your app, you can modify the applications, and sometimes there is no easy way to roll back. So it's a totally different approach. So here it's a simple lab environment. It's a status application. There are no any backend, just to show you how that feature works. In real production environment, it's more difficult, and you need to maybe have any test database. So because if you update schema, if you create new entries in a database, it's sometimes no way to go back. So maybe you should split your large system to more services and start to distinguish somehow what you are going to deploy with Canary and what you are going to deploy with a standard approach.
To summarize,
So
test.
yeah, thank you.
Why Traefik doesn't use the standard ingress object from Kubernetes?
Good question.
And I was looking that up while you were going on, and instead of me regurgitating what the documentation says it best. It basically says the community expressed the need to benefit from Traefik features without having to write tons of annotations.
Absolutely, because if you use a standard ingress controller instead of CRD, you have to use annotations, and it looks complex. And with CRD, if you understand how the CRD is designed, what are the objects responsible for, it's easier to create documentation. And personally, I started to play with that some weeks ago, and if you add some heart to it, definitely you will do that. So it shouldn't be difficult.
Jakub, could you please share your GitHub link in the chat box for everyone?
Absolutely.
Thank you.
Welcome.
All right, we have more questions. Don't go away, Jakub.
I'm not going anywhere.
Let's see. All right, the next question also, how does Traefik Canary work with Nomad? Nomad has Canary deployments, so will work in Traefik configuration still be necessary for actual traffic to load balance and route to the Canary container?
Yeah, so I test on Docker Swarm, Canary approach, and on CRD. I haven't tested yet on HashiCorp tools, but maybe it's time to play a little bit with that.
You have lots of spare time, Jakub. You could do that. No problem. So I'll just add in here. I've also deployed in Swarm and Kubernetes Traefik, and I would assume that it works the same way with Nomad. So it's just going to watch for new containers that spawn up, and it should load balance and route to these containers as well. Not speaking from experience, I'm just assuming that this is going to work. And the documentation also, I think, mentions.
Last time I've spoken with one of our colleagues from the community on Twitter that he played a little bit with Nomad and Traefik, so maybe we can ask him to prepare a demo for it.
Nomad is basically a lightweight Swarm. So Swarm is super lightweight already. Just take all the fluff out of Swarm, and then you have Nomad. So I'm assuming it's the same concepts in orchestration, so it should also do load balancing and everything as well. Next question. Jakub had minimum TLS 1.3, but added support for 1.2 in his definition. So I was wondering the logic behind this.
Wow. What's the logic behind this? Again, it was just an example to show you how to use middlewares and how to use the TLS options. So,
again, you can choose 1.2 or 1.3. So I think just for your demo, you're. Yeah. It's not production.
It's not production. It's
not yet. We're going to ship it after this meeting, right? Always be shipping. All right, next question. So does the type of configuration forces Traefik to use 1.3 before trying 1.2, or is that automatic given to go up to down instead of down to up for HTTPS? I think this goes back to the minimum TLS version again. So it always looks at the minimum and then goes up. So if your minimum was 1.3, it won't try 1.2. It will only stay 1.3 or higher if that exists.
I wonder, do you have any specific production issue with that, or you are just asking the question because that's something which we should give a try and explore more? Because if it's real production issue, definitely it's worth to spend more time on it. You can drop me a message, a colleague who asked that question on Twitter. I'm happy to explore it later on.
All right, next question is, I just swapped from Istio to Traefik. Should be good idea to get more information with comparison, production experience, and traffic reliability, TLS pass-through. TLS pass-through, deployment daemon set, etc. What's the overhead of the middlewares? Now, that's a good question.
Yeah, so I think it's much easier for me, especially, to play with Traefik instead of Istio. I'm not an expert of Istio, but I spent some time on Traefik, and I understood it very quickly. So the learning curve, it should be easier to start using Traefik. That's my recommendation. And we are using an open source solution, open source version that it's just not the daemon set, it's just one instance. It's not high available environment right now, especially that we are using a PVC that is assigned to only one node. And you can as a service manager try to create any high available environment for that. But maybe you can consider to use EE. That is already, that problem are solved. And yeah, so for me it was much easier to start with Traefik. That's why I selected Traefik, like an ingress controller. And it's deployed by just one instance. No high availability in my example.
I can kind of add to this. So the overhead and middlewares, we have several customers running production, both standalone Traefik and HA Traefik, and we have lots of middlewares enabled. And to be totally honest, we don't see any drop in latency, and we don't see any performance impact at all.
Yeah.
I mean, I'm sure if you have some crazy regex rules where it's like evaluating every URL, you might see some edge cases, but yeah, most of the configurations I've seen, it's quite straight through.
Absolutely.
Also, each router can potentially use a different set of TLS options.
Overhead, that way I am asking. 20% overhead.
So each router can potentially use a different set of TLS options.
Yeah. What are the pain points of HA with open source?
So maybe that question can be reframed a little bit. I don't know exactly. I think they're asking, each router have a separate TLS version? I think that's the question they want to ask.
Yeah, I think you can use TLS options to create a separate TLS version for each router, but that's something which we should test it. We can make a note and test it, and because I haven't tested, so I understand that this is the main purpose of TLS options configuration, but I haven't tested.
Typically how it works is like the static config is like the global settings, and then the dynamic config is specific to that router or service. And typically you can overwrite these settings at the service level, but yeah, it's something I would test anyway, just to make sure.
Absolutely.
Next question. Let's see, we have another one in the chat here. How do you deal with traffic redundancy and Let's Encrypt SSL management?
Yeah, so that's the good questions. And currently, if you use a built-in Let's Encrypt feature from Traefik. There is no easy way to develop HA. You can, what I recommend is to use a cert manager instead of that built-in feature. In previous version, there was a console that you can use key value store and store certificates, but it has been removed because there were some problems. So there is no easy way to do high availability with Let's Encrypt, because you have to store certificates in a storage. And of course, you can replicate the traffic horizontally, but you need to make sure that each of the instance has access to that storage in order to read certificates. Alternatively, you can think about EE, Traefik Enterprise Edition. That is, and that feature is solved there.
Yep. So, what do you use as a backend to store this information? So where do you store the certificates? How does it HA work? Can you kind of explain the components there?
Yeah. So in EE,
the open source version.
In Cert Manager, if you use a Cert Manager, it's a feature that comes from Kubernetes, and you can assign the certificates. You can say that each instance of traffic that is running on your cluster will have access to the Cert Manager. So it doesn't matter how it's configured. Traffic just read the certificates from Cert Manager. If you use Let's Encrypt, you need to store certificates in PVC on volume, physical volume. And if you don't provide any HA for any, it's assigned to one node, you cannot just create the HA in that configuration. So I recommend to switch to Cert Manager and don't use Let's Encrypt in that case. There was also one of, maybe not edge cases, but if you use certificates that has been issued by any external provider, you can build your own image of Traefik and put the certificates inside your Traefik image. And that container, that immutable container, you can store in your repository, in your Docker registry, and deploy that your own image. Of course, it requires extra work to maintain that image and to make sure that all of your certificates are valid in that container. So that's one of the example. And I use it in one company because we have a certificate that has been issued by any other company that is a paid certificate, and that certificate is put it inside to image. The image is built like a immutable container. Container is stored in our private Docker registry, and we are deploying that traffic using that image, and we can easily scale it up because everything is inside the image, inside that package.
And this kind of answers the other question I saw in the chat here from Juan. Can you do HA with the open source version of Traefik? What are the pain points of implementing that? So I think you kind of answered that. And the question, the answer is yes, you could do it with the open source version or the enterprise version. And the pain points is really the initial configuration, is really deploying it the first time, getting the certificates and the config files replicated across all the hosts. And that's really more an infrastructure question and not a traffic question, because this is something that you'll encounter with, databases or applications as well. Let's see, do we have anything else here? I think that's all the questions in the chat. Unless anyone else has further questions. Mert, do you have anything you want to add?
Yes, and Jakub, it was a great session and demo. Thank you. And I have a personal question for you.
Wow, thank you. Thank you for the nice words. Yeah, please ask me the question.
Okay, what is the best feature of version 2?
I like the CRD That's my, because I started to learn Kubernetes a few months ago, because I moved from Swarm to Kubernetes, and I like it because that's, for me, it's easy to understand and even move forward with the configuration using a CRD. And now I can create my own objects. So for me, I like the CRD the most.
Okay, Brian, do you have any questions?
Let's see. So it's more along the Canary deployments and really, how do you go about, setting up your services for Canary deployments? Do you have multiple services running, you said? And how do you determine, when to switch over to the service 2, for example?
But it's a totally different topic, I think, Brian, because it's defining service level objectives, to define the metrics, to determine, okay, the application is fine, the new version is fine, it does not cause any problem, we can switch it. But it's a totally different aspect, I believe. But yeah, I also like Canary.
Perfect. Patricia mentioned I think we've consumed all the time for today's presentation. Jakub, you did amazing. I think I want to hand it back to Patricia, kind of bring us home.
Well, I certainly wasn't ready for this spotlight. Yeah, thank you for joining us, and I just think we're good to go. And everyone who joined us, if you'd please follow us on YouTube to see the video, and stay tuned on Twitter or to our newsletter to hear about upcoming events. And I just want to say thank you to Mert, Brian, and Jakub for your time. And it's been a fascinating session, Jakub. Great job. And thanks to everyone for joining us today. So we'll see you around.
Thank you so much for your time, Mert, Brian, Patricia. Thank you for inviting me. See you shortly. Thank you so much.
Thank you, everyone.
You're welcome.
Great job, Jakub.
Bye-bye. Thank you.